Welcome to our intro to functions. We're going to start with three vocab terms: relation, domain, and range. Key terms of talking about functions. A relation is a set of ordered pairs. A set of ordered pairs. A domain are all the x-coordinates, where the range are all the y-coordinates. So if I have a list of points, this is called a relation, a set of ordered pairs. We have Perkins 346, Boyer 336, Mitter 339, Fisher 330, and Dupler 330. So what we're going to do is we're going to find the domain and range. We're going to list them. Our domains are all the x-coordinates. So that would be Perkins, Boyer, Mitter, Fisher, and Dupler. And then the range would be our room numbers: 346, 336, 339, 330. And see how 330 is written twice? We don't write it twice, just once. Using the same relation, now we're going to write them as a mapping. So mapping are visual representations of functions. You have your x-coordinates or your domain in one oval, and you have your range in the other oval, and you use arrows to represent your function, which x goes with which y. The arrows will always point to the right, starting from the domain, ending to the range. So our domains again were Perkins, Boyer, Mitter, Fisher, and Dupler. Our room numbers were 346, 336, 339, and 330. And what we're going to do is we're going to draw arrows mapping our function, showing where's it beginning, where's it ending. Boyer's to 336, Mitter's to 339, Fisher and Dupler are both in room 330. Now what we're going to do is we're going to talk about, is it a function or not? What you do is you take a look. A function by definition is a one-to-one relationship, so that every one x there is one y. So we take a look. I have one x and for every one y. Each x only goes to one number. Just because Fisher and Dupler are both in 330, there's two unique people that belong to one room. So, sorry, yes, this is a function because for every one domain there is one range. I'll even write that down on the board for you. For every one domain there is one range. So now what we're going to do is we're going to talk about inverse. Inverse is where you switch the x and y. Switch the domain and range. So the definition of inverse is switch domain and range. So the range now becomes the domains, so that would be our room numbers: 346, 336, 339, and 330. And then our range are now the people: Perkins, Boyer, Mitter, Fisher, and Dupler. Okay. Now we still always start our arrows from the right to the left, so from domain to range. So let's go ahead and draw those in, see what they look like. 346, that's Perkins. 336, that's Boyer. 339, that's Mitter. And 330 is both Fisher and Dupler. So is this a function? Well, this is not a function because for every one domain, 330, it has two ranges, not just one range. So one of the keys to pay attention to when you're looking at a mapping is the arrows. You're only allowed to have one arrow from one domain. 330 has two arrows coming off the same domain, but it's okay if it goes to the same number. All of these could have been the same number, as long as the domains have only one arrow coming from it. Okay, that is what tells you that there's one domain for one range. So what we're going to do now is just practice, determine whether each relation is a function. So what you do is you look to see, is there for every one domain, is there one range? So I look, 1, 3, 5, and 5. 1 has only one range, right? Yes. So the domains, again, are 1, 3, and 5. And let's talk about the ranges then. We have 2, 4, 6, and 7. But if you take a look at the 5s, this domain goes to one range, and this domain goes to another range. So this means that the same domain has two ranges, not just one range. So this is not a function. One way you can tell is in your domain, if the x's repeat, if your domains repeat, it is not a function. So let's take a look at the next example. I'm looking at my numbers, my domains. I have 1, I have 3, I have 6, and I have 7. That means all of these have a unique range, a unique domain to one unique range. So we know, yes, this is a function because none of the domains repeat. So now if we take a look at function notation. When we were talking about inverse and direct variation, we did address independent variable versus dependent variable. Some people were struggling with identifying for direct and variation, like which is your x, which is your y. So we brought up the topic of identifying your independent variable versus your dependent variable. Your dependent variable is your y, and your independent variable is your x. Because to know y has to depend on the value of x. Your take-home money depends on the number of hours you worked. So my dependent variable in this case is t, and my independent variable in this case is h, which represents the number of hours I worked. So if we take a look, function notation is read f of x or f at x, not times. Is not times. Most of the time in class I'll probably say that one. Sometimes if you're reading graphs that one might help. But this is function notation. F parentheses x inside of it, meaning f of x or f at x. Okay? So if we take a look, this kind of lays out how this function is represented. So your input is your x. Your independent variable is always your input, which is always your x coordinate. Your output is your y. It's telling you the result. What happens when x is this? What's the new result? Your equation is your standard equation with x and y in it, but instead of y, we now have f of x. So we read this equation as f of x equals $3 or 3.50h plus 4.75. So we need to find f of 30. This means evaluate the function by substituting 30 in for x. So what they're asking you to do is, how much money are you taking home when you work 30 hours? That's what we need to figure out. So you start the function with f of 30 equals, and now we just substitute that value in, 3.50 times 30 plus your initial $4.75. So after you do that, working 30 hours will bring you $109.75 is your take-home money. So now what we're going to do is we're going to just practice evaluating functions for each of these values. So f of 4 for f of x is equal to 2x plus 3. So you have f of 4 is equal to 2 times 4 plus 3. Well, 8 plus 3 is 11, so f of 4. So when f is at 4, the result is 11. So now we're going to do the same for h of negative 5 is equal to negative 5 cubed minus 2 times negative 5 squared plus 5. Again, be very, very careful with using your calculator here. If you get this wrong, it's because you didn't plug it in your calculator right. Have to use parentheses when substituting in a negative value. A negative number. I'll rewrite that in case you guys can't read what that says. That should say negative. A negative number, especially when you're squaring it or cubing it. So if you type it into your calculator exactly as I have it on the board, we find out that f of negative 5 is actually equal to negative 170. So if you take a look, part C, we have g of negative 2 is equal to 2 times negative 2 squared minus 1. So negative 2 squared, remember, is always a positive. Don't let your calculator fool you. So 4 times 2 is 8 minus 1 is 7. So g of negative 2 is positive 7. So g at negative 2 is 7. Now if we plug in a binomial, because we've seen these before in our last unit, you just literally substitute in that entire binomial as is, and then you just have to distribute. So f of a plus h is equal to fa plus 5a plus 5h plus 7. You can't combine anything, so that's your final result. And those are a couple examples on how to evaluate. Remember, the name of the game is substitution. Double check how you plug in negatives, especially into your calculator using parentheses. And then the last topic we're going to talk about is functions and tables. So function f is defined by the table that's given to you in your notes. And it says explain why the table defines a function. Well, this goes back to how do you know if it's a function? Because for every one domain, there is exactly one range, or only one range. So find the domain and range. So all we need to do is list our x's, negative 2, negative 1, 0, 1, and 2, and our range, same thing, 5, 0, 3, 1, and 4. And then it says find the indicated function values. So what this is saying is find f at negative 1. So they want you to tell us the y coordinate. So this is saying find y. So find negative 1 is x, here it is, and then it's associate the y coordinate is 0. So number 2, same thing, it's telling you find f at 0. So that means find find y when x is equal to 0. X is 0 here, so that means the y value is 3. This one even tells you in words, find x, such that f of x is equal to 4. F of x really stands for y. It's saying find when y is 4, what is x? So the answer to that is x is 2 when y is 4. So we have one more from a table. Explain why the table defines a function. Again, for every one domain, there is exactly one range. So find the domain and range. Our domains again are the x values, so 0, 1, 2, 3, and 4. And our range is 3, 0, 1, 2. Well, I don't need to name that 3 again because I already have it listed once. So I'm going to erase that comma. And then it says find the indicative function values. So again, when you see it written in function notation, it's telling you that x is equal to 1. So you need to identify what its y coordinate is. So then you look over here, x is 1, which means y is 0. So g of 1 is equal to 0. So we have to find g of 3, so find 3, and its coordinate is 2. So again, you're finding y in that case. And then the last example actually tells you to find x such that that g of x is 3. So x is equal to, we'll find 3 in the y coordinate now, the g of x column, and its corresponding x value is 4. Thanks.